Hi guys. Okay, today we're going to find the volume of some composite figures. All composite means is we're taking two of the shapes we already know, like cylinder and cone, and stacking one on top of the other in order to find the volume of a combined shape. Okay? Or we might be taking one shape and cutting a piece off of it, and so we'd be subtracting at that point. Okay, so composite volume means to combine two shapes or take a piece away. Okay, so what you're going to do is look at each diagram and think about what two shapes you're going to either combine or take away, and then write that down. So like the first diagram, I see a cone on top of a hemisphere. So I've got a cone being put on top of or added to a hemisphere. I'll just say hemi. Okay? Then we're going to write the formulas for each one. Now remember, you don't have to memorize the formulas. You have a sheet with the formulas on them. So formula for cone is 1/3 pi r squared h, then a plus sign. And a hemisphere is half of a sphere, so half times 4/3 pi r cubed. Okay, so in my cone, my radius is right here. That's also the radius of my hemisphere. My height of my cone is right there. So my next step is going to be to sub in. So 1/3 times pi times 4 squared times 10 plus 1/2 times 4/3 times pi, and it has the exact same radius. It's still 4 for the hemisphere as well. So 4 cubed. Okay, now on your homework you are being asked to solve the odd problems in decimal form and the even problems in terms of pi. So I'll just kind of switch back and forth during this video so that you are exposed to both. Okay, I'm going to answer this one in terms of pi. So that means that I'm going to type in, let's see, I'll use yellow. I'm going to type in everything I see except the pi's. I'm going to type all that in my calculator at once. Okay, so 1 ABC3, depending on the calculator you're using, I'm talking through the calculator steps for the calculator we use in class. So 1 ABC3 times 4 squared times 10, then the plus sign. 1 ABC2 times 4 ABC3 times 4 caret 3. Okay, and the calculator says 96, which is correct, and bring the pi down. So 96 pi would be the combined volume of those two shapes together. Okay, next one, I've got a cone on top and a cylinder on the bottom. Okay, my cone formula is 1/3 pi r squared h, and my cylinder formula is pi r squared h, no 1/3. Okay, so for my cone, my sub in here, pi, my radius is 5, and my height is 13. Okay, for the cylinder, it's the same exact radius, 5 squared, and the cylinder height is 2. Now this one I'm going to answer in terms of a decimal. which means I'm going to type everything in, including the pi. So 1 ABC3 times pi times 5 squared times 13 plus, a lot of people get really into typing the multiplication sign, and they just keep using that one. Don't forget to switch in the middle and put a plus sign. So plus pi times 5 squared times 2. And the decimal on my calculator, or the answer on my calculator, is 497.4. And I'm going to keep the 4 because there's a 1 after it, and 1 tells the 4 to stay the same for rounding purposes. All right, let's talk about a shape being removed. Okay, that means we're going to subtract. So in this case, I have a whole cylinder, or the large cylinder, and we're drilling out or removing a small cylinder. Now, cylinders have the same formula, pi r squared h minus pi r squared h. Subbing in, pi times. Okay, so I need a radius of the large cylinder. Well, the diagram says that the diameter is 7. I don't want diameter, I want radius, so I'm going to cut that in half. The radius equals 3.5. Half of 7 is 3.5. And the height of the large cylinder is 9. Okay, subtracting off the small cylinder times, pi times, okay, it's kind of hard to see in the diagram, but it's 3 centimeters, but that's a diameter. I don't want a diameter. I want 1.5 for the radius, half of 3. Now, the height of the small cylinder is the same as the height of the large cylinder. It's just a piece taken out. So this one we are going to answer in terms of pi. Okay, so let's see. I'm only going to type in this part, the minus sign, and this part. I'm going to leave off the pi's. So 3.5 squared times 9 minus 1.5 squared times 9. And I get 90. Bring down the pi, 90 pi. Okay, in the next diagram, it's really easy to see the smaller cone right here. Okay, and while I'm in here, we don't want 5.7 because that's the distance all the way across. We want half of that, which is 2.85. All right, so we know that a small cone is being taken off. All right, but what some students had difficulty seeing was that this is a large cone. So basically, this ice cream container shape comes from a large cone and then cutting off the bottom. Okay, so we've got the large cone minus the small cone. Okay, so cones have the same formula, 1/3 pi r squared h minus 1/3 pi r squared h. So now we're going to sub in large cone, 1/3 times pi times now r. 10 for the large cone represents all the way across. I don't want that. I want just the radius. So 5 squared. The height. Well, they don't tell me the height of the whole blue cone, but they do tell me what the pieces are. One piece, the ice cream container, is 6, and then the cone part that gets cut off is 8. So I can add those together and find out that the entire cone has a height of 14. Subtracting off 1/3 times pi times the small cone has that radius of 2.85 squared and the height of 8. So we did the last one in terms of pi. Let's do this one as a decimal. So we're going to type everything in, including the pi. So 1 ABC3 times pi times 5 squared times 14 minus 1 ABC3 times pi times 2.85 squared times 8. And my answer is 298.5. Now this was a 4 on the calculator. The 5 is a 4 on the calculator, but there's a 7 after it. 7 tells the 4 to round up to a 5. Okay? I also want to do one of the problems from the homework. Let's take a look at this homework problem. Okay? You can start off saying, okay, this is going to be cone plus hemisphere. So 1/3 pi r squared plus hemi is 1/2 times 4/3 pi r cubed. Okay, so I go to the cone and I'm looking for subbing in 1/3 times pi times, okay, I don't see the radius in the diagram. I do have the 7, which is the diameter. Okay, so I'm not using the 7, I'm using 3.5 for the radius. And now I need the height. Well, I know the height of the entire figure, but I want only the height of the cone, which starts about here and then goes up. That's the height of the cone. So knowing the height of the whole figure doesn't feel very helpful. Well, here's what you have to remember about spheres. Is this distance, this 3.5, is the same distance in every direction. It's 3.5. Every single one of those gray lines I just drew is 3.5. Pretend they all went as far as the edge of the circle. They're all 3.5, which means that the distance from the center of the circle down, this distance is also 3.5. Okay? So this part over here is 3.5. So if I know that this part is 3.5, okay, then I can figure out the yellow part by subtracting 15.5 minus 3.5. So the yellow part is 12, so the height of the cylinder, or height of the cone, excuse me, is 12. So I can sub that in. All right, hemisphere 1/2 times 4/3 times pi times 3.5 cubed. Okay, let's answer this one in terms of pi. So we're going to type in 1/3 times all this stuff and this stuff. Okay, we're just going to skip over the pi's, that's all. So 1 ABC3 times 3.5 squared times 12 plus 1 ABC2 times 4 ABC3 times 3.5 caret 3. Guys, I messed up. This is a homework problem. So we have to include the pi this time. Okay, so my bad, we have to include pi. So times pi, I'm going to put that in there. Okay, I'm going to start over again. Sorry about that. 1 ABC3 times pi times 3.5 squared times 12. Then the plus. 1 ABC2 times 4 ABC3 times pi times 3.5 caret 3. Just to give you a little heads up, I paused recording for just a minute, and one piece of advice I would have for you before you commit to an answer is look through what you typed on your calculator and proofread it so that you're sure that what you're typing off of is correct. So 243.7 is my decimal answer. Thank you. Have a good day.